So when the universe began about 13.7 billion years ago, it actually took about 1 billion years before the first stars would actually form. The only elements that were present at that time were hydrogen and helium. Mostly hydrogen, but there was some helium present. Now, what happens is inside of these stars, you have in the core of them hydrogen fusion happening here. So the hydrogen fusion happens inside the core that begins to create helium. Now, eventually over time is the core will begin to contain more helium than it would hydrogen. So you're going to have a helium core and then a ring of hydrogen fusion surrounding it. Now, as for what's in this area, this is all hydrogen as well. It's just not undergoing fusion because it doesn't have enough heat and pressure. So we have a helium core with hydrogen surrounding that helium core, and the helium is undergoing fusion. Some of that helium is fusing with hydrogen, some of it is fusing with other helium. So if it's hydrogen and helium, you're going to get lithium. If it's helium and helium, you're going to get beryllium. Now, over time, what will happen is the denser elements, which are the higher level elements, are going to sink towards the middle, and you're going to end up developing a core with the most dense elements, and then around the core, the next level elements, then the next level elements, then the next level elements. And basically, these massive stars are kind of like an onion where they have multiple layers. Now, the more massive the star is, the more heat that can be generated. And the more heat that can be generated along with the greater pressure, the higher level elements you can make. So we started with hydrogen, and we got helium, and we got lithium and beryllium. As the fusion continues on, you're going to get your heavier elements like carbon, nitrogen, oxygen, on and on and on. And that fusion is going to keep happening, and more layers of this onion, if you will keep building until eventually you reach iron. And then the core of the star itself is iron. Now, we looked at this before when we talked about how can you possibly get energy out of both fusion and fission. And then we talked about how iron is the magic element. Iron has the least mass per nucleon. So whether you put iron under fission or fusion, what will happen to iron is it will take more energy than you will get out of it. So it's a negative return. You could theoretically do it in a lab and force iron to fission or fusion if you had enough excess energy to supply for the reaction to occur. However, that doesn't happen naturally inside of stars. So what we get inside of these massive stars is all of the elements that are at or below the 26th element, which is iron. These supermassive stars are 20, 30, 40, 50 times the size of the sun. They are incredibly huge. And you would think, well, if they're so huge, then they should live longer than our sun. But the truth is, because they are so big, they can undergo more fusion processes at a particular given time. Therefore, they will burn through their fuel at a much faster rate than our own sun. And these massive stars only live about 100 million years. I say only 100 million years, but to put that in perspective, this star goes through its entire life cycle 100 million years. The sun is going to take about 10 billion years to complete its life cycle. So although these stars may be 40 to 50 times the size of the sun will actually live about 100 times as long. Ultimately, though, all of your elements from hydrogen to iron were forged inside of these supermassive stars. And these supermassive stars, although some still do exist and some still do form now, in the early universe, almost all of the stars were supermassive stars. And that's what created all of the heavy elements that we see here on Earth today.